Hello guys, welcome back to another geography lesson, and we're busy with revision in the past question paper, and today we're going to discuss question number 2 that consists of climate and geomorphology. Now keep in mind, read your instructions, you only need to answer one question from section A, but you can do the second question as well, but remember, only answer 3 questions. Do not do all 4 of the questions. But let's continue having a look at question number 2. Question 2.1. Refer to figure 2.1 showing 2 pressure cells in the southern hemisphere. Now there's your first tip. Southern hemisphere. Indicate whether the descriptions below refer to pressure cell A or B. Now let's just quickly have a look at the pressure cells. Now the first one over here, as you can see, is rising air. So your first clue, rising air, pressure, is usually a low pressure. And what do we know about low pressure in the southern hemisphere? Clockwise circulation of air. Another tip, as you can see, if you look at these arrows, is convergence of air. Now if you look at number B, what do we have over there? Sinking air, subsidence. And sinking air is associated with a high pressure. And because it's in the southern hemisphere, what do we say? It's anti-clockwise circulation of air taking place. Now just by looking at the diagram and looking at the arrows, we can get some sort of clue what these pressure cells are. Now the first question, an example of a high pressure cell. If you go back to the diagram, we've already established you've got sinking air over there, so the correct answer will be B. 2.1.2, the air converges in the pressure cell. If you look at the diagram, convergence taking place. What does convergence mean? Coming together. So the correct answer will be A. If we look at 2.1.3, this pressure cell dominates the land in winter over South Africa. Now, if we look at winter conditions in the interior of South Africa, we experience clear blue skies. Now, how do we experience clear blue skies? Keep in mind, for the cloud formation, what do we need? We need rising air. Clear blue skies, the reason why, because we are dominated by a high pressure system, and by now you should know that high pressure system is known as the Kalahari high pressure. And so the correct answer for 2.1.3 is going to be B. The air diverges from the cell. We've already had that question. So that's also going to be B. If we quickly look at question 2.1.5, associated with clear skies and stable weather. Same questions as before. It's sinking air. So that means clear blue skies. When there's rising air, the chances for cloud formation are much better for condensation to take place. So the answer for 2.1.5 is also B. Also known as a cyclone. What do we know as a cyclone? If you go back, we look at a tropical cyclone, we look at mid-latitude cyclones. What type of pressures are they? They are low pressure systems. The tropical cyclones are low pressure because of very warm tropical conditions. The mid-latitude cyclone is low pressure because of the cold air forcing the warm air to rise. So the correct answer for 2.1.6 is A. Now 2.1.7, associated with warm air rising, that's a low pressure system because of warm tropical conditions or because the air is being forced to rise, for instance, a mid-latitude cyclone. As the cold air approaches, what does it do with the warm air? It forces it up. Associated with a tropical pressure belt, there you go, there's a giveaway, tropical, warm conditions, low pressure system. If you look at the equatorial low pressure belt. Our next question shows us geomorphology and shows the landforms. Now immediately, if we just look at the diagram, I can see a river meandering. And over there at E, I see stream braiding. Now, and D, we can classify as an oxbow lake. Now, very importantly over here, in which stage of the river does this take place? It's usually deposition, and that's in the lower course of the river. But let's quickly look at the questions that's being asked in this question paper. Name the outer bank of the river labeled A. Now let's quickly look at the outer bank. It's this area over there. Now what happens over there? We know it's prone to erosion. It's not like we can steer the water. So the correct answer for A will be the cutback slope. Does the inner bank B of the river experience more erosion or more deposition? Let's quickly have a look. B is situated over there. Definitely deposition. If I can draw a transverse profile from the one riverbed to the other one, A is going to be a concave slope, where B is going to be a gentle riverbed slope. If you look at the transverse profile of it, over here erosion takes place, and on this slope number B, deposition takes place. So the correct answer for 2.2.2 will be deposition. If we continue with our questions, name the fluvial feature labeled C. Let's quickly go back to our diagram. C over there is a meander. What is the feature D called after it dries up? Now it usually dries up during dry season. If we quickly look at D, situated over there, when it dries up, when there's no water in it, it's known as a meander scar. Meander scar. Name the stream channel pattern labeled E. That's where deposition takes place. If you can look over here, now that's definitely a braided stream. It's one of the characteristics that we find in the lower course. And the next question is feature E formed by erosion or deposition. Now definitely deposition. The reason for it, because in the lower course what happens, there's no erosion taking place. All the materials that's been eroded, the vertical erosion took place in the upper course, lateral and vertical erosion took place in the middle course, and all of that materials, the sediments, are being deposited in the lower course. So your correct answer for 2.2.7, 2.2.6 is deposition. There's no erosion taking place in the lower course. Is feature C generally found in the upper or the lower course of the river? And that will definitely be the lower course, like I just explained. Our next question is a synoptic chart. Now once again, before we're going to answer the questions, just quickly look, let's go and look at all the clues that's on the synoptic chart, and we can determine what's happening over here. Now first of all, what stands out over here for me is the high pressure system over the interior. Now this high pressure system only occurs during winter months, and this high pressure system that dominates the interior is known as the Kalahari high pressure system. What else can we identify? Go and have a look at the weather station models. As you can see on the weather station models, we experience clear blue skies. So that's another indication of the high pressure system over us. Because it's subsidence, it's sinking air, so now no cloud formation can take place. If you look at the weather systems over there, weather station models over there, and you can see that the temperatures are quite moderate, not as warm as it is in summer. Now if you look a little bit further on the synoptic chart, we got the South Atlantic high pressure over here. But what's interesting over here, the isobars are elongated. If you look over here, There's the isobars of the South Atlantic high pressure. And as you can see, it ridges in over the western coast of southern Africa. And then last but not least, what do we have here? A low pressure system with a cold front attached to a warm front, and that's a mid-latitude cyclone. Now let's quickly look at the questions that's being asked regarding this synoptic chart. Identify the three pressure systems labeled A, B, and C respectively. Now A is the Kalahari high pressure system, B is the South Atlantic high pressure system, and C is the mid-latitude cyclone. So let's quickly go and fill this in. A is the Kalahari high pressure, B South Atlantic high pressure, and C is a mid-latitude cyclone because it's a low pressure system. Explain why the high pressure cell A limits rainfall over the interior of the country during winter months. Now, as you can see on the weather station models, most of the weather station models don't show any rain formation, precipitation, and cloud cover. The reason for this is because of the strong subsidence of the high pressure system over South Africa. So if I can quickly draw a cross section, basically in winter months what happens, the Kalahari high pressure system creates a strong subsidence, sinking air. So it doesn't allow the warm, moist air coming in from the east coast of southern Africa to reach the interior of Johannesburg and the Free State. So what's being created over here? Inversion is being created. So the moist air can't reach the interior and it can't rise to cool, condense, and cloud formation. And because of the strong subsidence of the Kalahari high pressure, sinking air, it creates stable conditions and clear blue skies. Okay, if you look at our next question, 2.3.3, what evidence on the synoptic weather map suggests that high pressure cell B is ridging? When we discussed the synoptic chart, elongated isobars, as you can see, this high pressure system is ridging in over the west coast of southern Africa. So, right there, elongated isobars over the west coast. Now, evaluate the negative impact of the cyclone labeled C on the economy of South Africa. Now, keep in mind, this mid-latitude cyclone, excuse my pun, creates Mediterranean climate for this area over here. Now, believe it or not, there's positive impacts of this mid-latitude cyclones, and we experience some negative consequences as well. Now, first of all, it creates Mediterranean climate. Now, if we do experience cyclogenesis and a family of mid-latitude cyclones, it can create high precipitation. Now, first of all, what it can do, it can create floods down in the Western Cape. And with the floods, it means crops can be destroyed. And that will have a negative impact on the farming community, and it will have a negative impact on South Africa's GDP, because what do we need to do now? Now we need to import food instead, where we make money, where we can export it. Another consequence, a negative consequence of it, it means food prices can increase because of all of these floods. It can damage infrastructure. And the snow can kill livestock. Another example that we can use as well, because Cape Town is quite a big tourism industry, it can have a negative effect on the tourist industry because people won't come and visit. So the tourism industry will be influenced. Will be negatively influenced. And because of this flooding that was being experienced, what can we say? We can also mention that because of the poor conditions, it can lead to more accidents, for instance on the road. Okay, let's quickly go and have a look at our next question. Now, 2.4, figure 2.4 below is based on valley climates. What do we know about valley climates? It's local climate. Now, local climate, if you look at the diagram, immediately what can we pack up? Situated in a valley, as you can see over there. And one thing that I've noticed over here, we got sinking air taking place. Now, sinking air, does it take place during the day or during the night? Let's quickly find out directly after the break. Stay tuned.